Good morning, students. Class 9. We completed the previous chapter, Force and Laws of Motion. Now I am back with the other chapter, Gravitation, and this is the last chapter before Summative Assessment 1, Essay 1. Well, by the way, this chapter is going to be very interesting because gravitation chapter somewhere attracts all the attributes or possibilities that we look for, that we like to know for. Okay, this universe is basically working on the mechanism of gravitation, and a lot of stories we have read about this gravitation. So who could forget this legendary story of Sir Isaac Newton? Sir Isaac Newton proposed the gravitational law and all the implications and solved all the possible intricacies related with this term gravitation. Students, the legendary story, what is the legendary story? The legendary story is that one day while Newton was sitting or napping under an apple tree, a ripe apple fell on his head. Yes, it happens. It happened. A long way back, this story is a long way back, later earlier in the year, like the 18th century, 1770s around. Okay, so this legendary story, everybody of you have heard, I guess. So, students, he actually knew from the first law of motion that a net force should have acted on the apple to make it fall from the tree. This simple event prompted Newton to imagine, okay, that perhaps all bodies in the universe are attracted towards each other. Newton's third law: to every action there is equal and opposite reaction. Similarly, he just imagined all the phenomenon into that context, and this simple event prompted Newton to imagine all bodies in the universe are attracted towards each other. In the same way, the apple was attracted towards the earth. To prove it, he analyzed a lot of data. Yes, students, a lot of data he analyzed on the motion of moon around the earth. From these studies, he concluded that the force of attraction, which causes the motion of the moon around the earth, is same as that causes an apple to fall from a tree. So students, based on these findings, he postulated his famous universal law of gravitation, and that law of gravitation is known as universal law of gravitation, and this is very important law we should learn in this chapter. What is the law? Let us see. He stated that every particle in the universe attract each other with the force of attraction, and that force of attraction is directly proportional to product of their masses. Okay, like the moon, and between the moon and earth there is sort of gravitational force. All right, students, we will have to understand very keenly here that the force which is exerted by the earth on the moon and the force which is exerted by the moon on the earth, somewhere we find this evidence that these gravitational forces in the form of ocean tides. Okay, so students, this gravitation is going to be very interesting. He said that every particle in the universe attract each other with the force, and that force of attraction is directly proportional to product of their masses, but inversely proportional to square of the distance between these two bodies. Let us see. Okay, what is the universal law? Students, suppose this is one body, this body is A, the body of mass is capital M I am taking, okay, capital M, the mass of body A, capital M. Now let us take one another body, this is body B, and mass for this body B, small m. Alright, so surely these two bodies will apply a force on each other, okay, and only force of attraction is applicable in the gravitational law, nothing else. You cannot imagine about the force of repulsion here. So students, force which is applied among these two bodies, alright, is directly proportional to product of their masses. That means, what is the product of their masses? First body is m, other body is small m. Okay, both are m, but one is capital M, other is the small m. So this is relation number 1, equation number 1. Alright, now the distance between the two distinct bodies is here r. Okay, what is the distance? The distance is r. But this distance is inversely proportional. A square of this distance is inversely proportional to the force. And this has been concluded by Sir Isaac Newton, and he proposed one law, inverse square law. I will also discuss about the inverse square law, but initially you try to understand here that F, that means force of attraction, is inversely proportional to square of distance 1 by r square. This is relation number 2. This is also known as, students, inverse square law. I will discuss it further, not now. So students, this has been written in the words, in the form of statement, which is known as universal law of gravitation. So we write that every particle in the universe attract each other with the force of attraction, only force of attraction, with the force of attraction which is directly proportional to product of their masses, that means m into n, and inversely proportional to square of the distance between them. So this law was proposed by Sir Isaac Newton. Okay, every particle in the universe attract each other particle with a force that is directly proportional to product of their masses and inversely proportional to the square of the distance between them. This direction of the force is, students, along the line joining the two particles. Alright, so here we could elaborate a little bit. Students, how can we move further mathematically? From equation number 1 and 2, we could write from equation number 1 and equation number 2, F is proportional to m into m by r square. Correct? If I write collectively from equation number 1 and 2, what we are going to get? We are going to get this one, F proportional to m into m by r square. Now, when proportion sign is replaced by equivalent sign, equal, then we give one constant term. Alright? Here, since we are talking about the gravitation, so the gravitational constant will be put over. So G is the gravitational constant. So G into m by r square. Okay, students, where we could write F is what? Gravitational force. F is gravitational force. G is gravitational constant. Gravitational constant. And the value for gravitational constant is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, and this gravitational constant was also proved mathematically. It was obtained by Henry Cavendish, one of the popular scientists. So F is gravitational force, G is gravitational constant, M, capital M, and this M, these two are the masses of the two bodies, and R is the distance between these two bodies. M and M are masses of two bodies. So students, we could write also from here G equal to Fr square by M into M. So we could obtain one more relation for the gravitational constant. Okay, now there are some mathematical cases which could be possible here. And what are those possible? Let us learn here. Students, case number 1. If the distance between two bodies is doubled, then gravitational force becomes 1/4. This is one of the cases I am discussing right now. Students, what do we know? F equals to what? F equals to, we know here, Gmm by r square, right? Let us consider it as equation number 1. Now, what happens if the distance gets doubled? Distance, that means new distance, r dash, becomes double. So 2r. So what will be the new force? It will be the F dash. So Gmm by r. In place of r, we are going to write r dash square. So Gmm by 2r square, that means Gmm by 4r square, equation number 2. Now students, F dash by F, if I divide equation number 2 and equation number 1, okay, what will happen here? Gmm by 4r square by Gmm by r square. So Gmm by 4r square, that means r square by Gmm. So this gets cancelled. R square gets cancelled. This is 1 by 4. So F dash by F equal to 1 by 4. So resultantly F dash, that means new force, new gravitational force, equal to F into 1 by 4. So what you have seen, 1/4. Gravitational becomes 1/4 of the previous one. I hope you have understood this case number 1. Now we will also discuss case number 2 in the context of this gravitational law proposed by Isaac Newton. Now students, case number 2. In case number 2, if the distance between two bodies is half, then gravitational force becomes 4 times. So students, we will write when the distance is r. When the distance is r, what is the force? F equal to Gmm by, okay, this r, capital R you can write, you can give equation number 1. Okay, you can give small r as well as capital R, no worries. But when the distance between two particles becomes half, that means r dash becomes r by 2, half of distance. So what will be your new force? F dash equal to Gmm by r by 2 whole square. So Gmm by r square by 4. So 4 will be going to the numerator part. Alright, again equation 1, equation 2, division will be given. So 4gmm by r square by gmm by r square. So 4gmm by r square into r square by gmm. This is getting cancelled. So 4 by 1, that means 4. So f dash by f equal to 4. So f dash equal to 4f. So what is the new gravitational force? 4 times of the previous one. Okay students, I hope you have understood today's class. Thank you very much.